Hello everyone, welcome back. Today's let's start how applications scale when user grows. So, imagine you build an application, small blog application or an online store. At first, one server handles everything, but your blog goes viral or your online store goes viral through an Instagram video or anything. So thousands of the user arrive and that one server starts to struggle. So we need to separate the app's brain and memory into the web tier and the data tier. So let's come and discuss about this diagram. So as I said, we separate the app's brain. So brain is the web server and the memory is the database. So we need to separate it out so that our application works more efficiently. So let's discuss about the database. So database is just like to store the data, and if user want to read something from your database, so we have one get request. That get request takes the data from your database and returns to you. But if you are updating something like you add something in your card, so in this case we need to update or we need to perform the right operation in your database and returns the data to the web server, and the web server return that data to you. Okay, so we have two different choices to choose which database we need to use. So we have two types of the database. So first one is the SQL and the other one is the NoSQL database. So SQL database are like the Excel sheets in a blank structured rows, fixed columns, and the strong relationships. They are perfect when your data is connected, like the profiles and the transaction. So in the SQL database, we have rows, we have columns, and the our all structure is just like the tables. But in case of the non-SQL database, we have unstructured data. We have data in the form of the key value pair, and something form of the graph and the column document is stores. So in the NoSQL database, we have one limitation. We cannot perform join operations, generally not supported in our NoSQL databases. So our next slide is when to choose NoSQL. So you choose non-SQL when speed and scale matters a lot. For example, Uber needs real-time driving tracking. Netflix store massive unstructured viewing data. When moving data fast is the priority, so the NoSQL wins. So yeah, so where the speed is matters and the real-time updates are very frequently. So in that case, we use the non-SQL databases. Okay. So our next slide is about the vertical scaling. This is very important topic for your interview perspective. So sometimes the interview asks, you know about the scaling and be confused. What's the scaling is? So for example, previously we only have one database and our one database is handling all the write read responses from the users. So what will what will happen in this case if the if loss of the request is increased and our one database is not enough to handle all the request? So we have a scale up or scale up or scale up of a server. So in vertical scaling means making one server stronger, more CPU and more RAM. So it's very easy to increase the power of our CPU or to increase the RAM, and it's very simple to implement for the low traffic. So it is easy to first, but there is one disadvantage over it. So there is one hard limit if that one server fails, like you are using only one server having the high CPU, having the high CPU and the more RAM. But let's imagine this server crashes and everything goes down. So this is not good impact for your application and not good for the user response. So what's come in the picture now? So the horizontal scaling come in the picture in that time. So horizontal scaling means adding more servers instead. This is how companies like Google and the YouTube scale. If one server fails, the other server keeps the system running. For example, here we are having multiple databases. So we are performing write on one database and read from the other databases, and we are also sync our write operation with all our read databases as well. So let's imagine if our this server goes down, so we have we have one more database, so we can make this database as the master database on which write or the upgrade operations are performed, and the rest too are able to complete our read operations. Yeah. So our next slide is solving the traffic problem. So how our web server identifies which database we need to use. Direct user connection fails if the server goes down. For example, our web server redirecting our request to this server and this server fails. So what happened in this case? So this is where the load balancer comes in. It acts like the traffic controller, distributing users across server so no one get overloaded. So for imagine this is our load balancer, and if this server having 100 requests and this is having 50 requests, so the load balancer have ability to redirect the 51st request on this server, not on this server, because this server already handled lots of the request. Yeah. So it's act like the traffic controller distributing users across servers so no one get overloaded. If during huge traffic spikes, your application stays fast and reliable. So yeah, so that it's for this video. Follow for more system design concepts. Make simple.